morning. So today we're going to be going over lesson 4, session 1. So that means we should be opening up our Ready workbook to page 81. Just a reminder to make sure that you get your iReady lesson done, and you can do so by clicking on this link here because this PowerPoint is available for you if you ever want to go back and look at it again. Your homework is going to be pages 85 and 86, which if you click on this link will bring you down to the slide that shows what questions those are. So today we're talking about a dilation, and a dilation is a transformation that makes a scale copy of a figure. So that means it is the same shape, it's just going to be smaller or larger. So kind of like this picture here, how they are the same, just this one's smaller than this one. When you dilate a figure, you start from a point called the center of dilation. So when you dilate a figure, like I mentioned, it either reduces it, so it makes it smaller, or enlarges it, which makes it bigger. A dilation is not a rigid transformation, and we know this because a rigid transformation does not change the size or the shape of a figure, and since a dilation does change the size, that means a dilation is not a rigid transformation. So our answer is a dilation a rigid transformation? No. A dilated figure is what is called similar to the original shape or original figure. And that means that it's the same shape as the original one, so it has corresponding side lengths. However, it might be a different size. So that means they are similar to each other. So like I mentioned before, this one is just a smaller version of this one. So these two would be similar to each other. So for our first problem on page 81, we have triangle ABC and triangle A prime, B prime, C prime. So we have our original figure in blue here. And we need to see what the side lengths would be of our new figure if we have a scale factor of 2. So when given the scale factor, that tells us how much we're going to grow or shrink our original figure. So when we have our original figure has 3 by 4 by 5, and we are using a scale factor of 2. That means we take all of our original lengths and multiply them by our scale factor to find our new lengths. So we have 3 multiplied by our scale factor of 2 to get 6 for our new A prime, B prime. 4 times 2 is 8, so there's our new A prime, C prime. And then 5 times 2 is 10 for our B prime, C prime. So you can see A to B was 3. 3 times 2 is now 6. A prime C prime, or AC was 4. Now it's 8 because we multiply 4 by 2 and get 8. And then we do 5 times 2 and get 10. So again, a scale factor, we are just multiplying our original lengths by that scale factor to find the new lengths of our new triangle or new figure. So again, when you dilate, one way is to enlarge it, so that would make it get bigger. So if you have a scale factor greater than 1, that makes it get bigger. Another way to dilate is also to reduce it, which makes it get smaller, and that's if you have a scale factor that's less than 1. So say that you have a scale factor of 50, that means your image is going to get bigger. If you have a scale factor of, say, 1/2, it's going to get smaller. So if you had a scale factor of 1, that means that you are just going to keep the shape as it is. Because remember, any number multiplied by 1 is going to be equal to that original number. So if you have a scale factor of 1, it does not get bigger and it does not get smaller, it just stays the same. So like I mentioned, a scale factor of 1 does not make it bigger, it does not make it smaller, but it makes it the same. When it comes to dilations in the real world, now we're on page 82. Go ahead and take a minute, pause this video in a second, and write down some examples of real dilations in the real world. So pause this video until you're done. Sorry about my dogs. So, some dilations in the real world. So, like if you were to go to Starbucks, they have the different size coffee cups. Or like anywhere, if you get different size cups for your drinks or your sodas, stuff like that. So like at Starbucks, they have what's called their tall, grande, and venti, and they're all the same. They're all the cup. However, they're different sizes. So this would be a dilation in the real world because we have our smaller one, our medium one, and our large one. Another example is what's called these Russian nesting dolls. That's those dolls that go inside of each other. So we have our biggest one, and then inside of it's this one, and then inside of that one's this one, etc. And they just keep getting smaller and smaller, but you can see they are the same shape. Another example is your eyes. So as a volleyball coach, I need to know about whether my players have a concussion, and one of the ways I can check that is by looking at their eyes. So as you can see here, this is where your eye is normal. You have that small little black dot. After it's been dilated, it'll be larger like that. So if my player hit their head on something, I'll pull them to the side and look at their eyes to see if they're dilated. Because if they're dilated like this, that's one sign of concussion, and then they'll need to sit out. So now the question is, which of the following is an example of a dilation? So we have playing with the Rubik's Cube. So remember, that's our rotation, so that's not a dilation. Then we have using a conveyor belt. So remember, that's when things move around. So that's a translation. So that's not a dilation. Looking in a mirror. That's a reflection. So that's not a dilation. Shrinking a photo. So remember, when you shrink it, you're making it get smaller, and therefore that is the dilation. Now we are on page 83 under the model it. So it says in art class that Kennedy draws a scale copy of figure A here in blue to make a rug pattern like the picture here. She's using a scale factor of 3/2, so that's the same as 1.5 to draw figure B. So since our scale factor is greater than 1, that means it's going to enlarge the image. So we need to complete figure B by drawing the missing sides. So the way we figure that out is first we take our side. So we can see this top side is 4 long, and we need to multiply it by our scale factor. So 4 times 3/2, and then we have our side lengths here of 2. So then we do 2 times 3/2, and we can see that these are all 2. This is 4, 2, 2, 4, 2, 2, 4, etc. So we just need to find these 2. So when we do that, we see that 4 times 3/2 is equal to 6, and 2 times 3/2 is equal to 3. So that shows that this top part is 6 long. 1, 2, 3, 4, 5, 6. And our side lengths are 3 long. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, etc. Now we're on to question 2. And it says Kennedy now uses a scale factor of 1/2. So remember, that's less than 1, so that's going to shrink our image. And now we need to complete our drawing. So the first step we're going to do here is, again, we have 4 by 2, and we need to multiply each of those numbers by our scale factor. So 4 times 1/2, and then 2 times 1/2. When we do 4 times 1/2, that is equal to 2. And when we do 2 times 1/2, that is equal to 1. So now we have, instead of 4, we have 2. Instead of 2, we have 1. So 2 by 1, 1 by 2, 1 by 1 by 2, 1, 1, 2, 1, etc. So that they match up. So you can see they're still the same shape, they're just reduced now, they're smaller after being dilated. Now, the other way you can do with dilations is that dilations will also find a way to find the scale factor. So say that you have your original figure and your new figure and you're trying to find the scale factor. You do so by dividing similar lengths. So you're always going to do your new one divided by your original. So for example, the height of the new figure is 6.5, so 6.5, and the height of the original figure is 4.5. So we're going to do 6.5 divided by 4.5. And when we do that, 6.5 divided by 4.5, we get 1.6. So that would be our scale factor. But we'll double check by also doing the width. So the width of the new figure is about 4.5. So we have 4.5 for our new figure. And then here it's about 3. So 3. So when we do 4.5 divided by 3, we also get 1.6. So that shows us that our scale factor is 1.6. So again, this means that if you are given the scale factor and you're trying to find the length of the new figure, that you multiply whatever the original is by your scale factor. And then if you're trying to find the scale factor, you will divide your new figure divided by your original figure. And make sure you always do it in that order. because it's important that you always do new divided by old. For question 3, it says a dilation may change a figure's size. In a dilation, corresponding angles are congruent and corresponding side lengths are related by the same scale factor. We need to complete the table to determine whether Q, R, and S are dilations of figure P. So we have figure P is our original, and that's 8 by 4. So we have 8 by 4. And we need to figure out is figure Q here, so this one in pink, a dilation. So we can do so by taking that length. So for our P, we have 8 by 4, and for our Q, we have 6 this way by 2. So now we need to divide to see if we get the same scale factor. So we have to take the similar. So 8 for our length of our original, and then Q, our length is 6 of our new. So remember, new divided by original, so 6 divided by 8, which equals 0.75, or 3 over 4. Then you again have to do that with the other side length, so you take your new one, so that's 2, divided by your original, that's 4. 2 divided by 4 is 0.5. Since 0.75 does not equal 0.5, that means it is not a dilation. So while the corresponding angles are congruent, because they're all 90 degrees, the corresponding sides are not multiplied by the same scale factor, because in one, for this way, the scale factor is 0.75, and for this part, it's 0.5. So figure Q is not a dilation of figure P. Now for figure R, the one in green, we can see that our figure at the top this way is 4 units long. 1, 2, 3, 4, whereas figure P, it's 8. So we need to do 4 divided by 8, and we get 0.5. Then we need to do the same for the side length. So we have 2 here of our new, and then 4 for our original. So 2 divided by 4 is also 0.5. And since 0.5 is equal to 0.5, that means that figure R is a dilation of figure P. So our angles are congruent, and our corresponding sides are multiplied by the same scale factor. Lastly, for figure S here is 12 units long this way by 8 units long this way. So we take our new for our length, so we have 12 divided by our original 8, which is 1.5, and we do our new here, which is 8 divided by our original 4, which is also 1.5. So we do 12 divided by 8 and get 1.5. And then we have our new 6 divided by 4, which is also 1.5. So our corresponding angles are congruent because, again, they're all 90-degree angles. Our corresponding sides are multiplied by the same scale factor because they both are multiplied by that scale factor of 1.5 below, which means that it is, in fact, a dilation of P. So Q is the only rectangle in the example that is not a dilation of P because corresponding sides are not multiplied by the same scale factor. For question 4, we see we have a point from which a figure is dilated. It's called the center of dilation. So like in this example right here. The center of dilation can be inside, on, or outside the figure. So it doesn't matter exactly where it is. When we start using graphs, it will always be, for the most part, at the origin. We want to use a straight edge to draw a ray from the center of dilation through each set of corresponding vertices of figure R, P, and S. So we have our center of dilation point right here, and we just need to draw our line so it goes through corner of R, corner of P, and the corner of S. And you're going to do that for all 4 corners. So if the figures are dilations, you can draw rays from the center of dilation through each pair of corresponding vertices. So the corner of R and the corner of P and the corner of S. And since this ray goes through all of these, that's why we know that it is a dilation. And we want to try to draw a ray for part B of can you draw rays from the point shown through each pair of corresponding vertices of R and Q. As we already discussed, Q is not a dilation, and so you can see that in the figure there about how the 2 arrows through the corner of arrow, or through the corner of R, it goes this way, and corner of Q is there, and so they do not go through each other like they do up here. So we cannot. So then for a reflection, it says, does a dilation change a figure's shape? So as we have discussed, a dilation changes its size, but it does not change its shape. So a dilation is different from a translation, rotation, and reflection, because remember that a translation, rotation, and reflection are all rigid transformations that do not change their size or shape. However, a dilation only changes its size. So a dilation changes its size, but not its shape, and a rigid transformation, like a translation, rotation, and reflection, does not change its size or its shape. So then, as we've discussed before, does not change its shape, but it does change its size for a dilation. And when it comes to those rigid transformations, it does not change its size or its shape. Lastly, your homework is going to be pages 85 and 86 in your Ready workbook, and that'll be due tomorrow at 9 a.m., October 5th. It looks like this. So first, you're going to say what a scale factor is in your own words, what you know about it, some examples. Remember, we talked about scale factors today, and some more examples down below. Then for question 2, it says figure B is a scale copy of figure A. Circle the scale factor that was used. So remember, this is your original figure, and this is your new figure. So you need to do your new divided by your original to find your scale factor based upon the corresponding parts. Then for question 3, it says that you're in a woodworking class and Eduardo makes a pattern for the top like so, and he wants to use scale copies. So you need to finish the drawing of L and K to show the scale drawing for part A, and then part B says to use another scale drawing. So for figure K, you're using a scale factor of 2. So remember, you're going to multiply all of your original by 2. And for L, it's asking you to do a scale drawing with a scale factor of 1/2. So then you're going to multiply all of your original points by 1/2 to draw your figure L. Lastly, number 4 says that Layla draws figure C, so in blue, as the original, and then they draw figure D and E here. Then you need to draw, and then this is your center of dilation, point F. Draw your arrows to see which of these shapes are a dilation of figure C. Other than that, that is all of your homework. If you have any questions, remember you can email me or call me. Other than that, have a good day. Bye.